Hello everybody, welcome back to another video. In today's little recording that we have here, we are going to be going over a few of the Weather Prediction Center's mesoscale discussions. Now, from the last video that I've posted, besides this one, you will know that I will have talked about the Weather Prediction Center day 1 through 5 outlooks from today through tomorrow and into Monday, Tuesday, and Wednesday. Uh, Basically, the Weather Prediction Center does what the Storm Prediction Center does. You know how the Storm Prediction Center issues mesoscale discussions, and they're for a severe weather hazard, an area of severe weather that is either expected to have a watch or not have a watch. This is essentially what the Weather Prediction Center does, except these are not related to like watch probabilities. These are just observations, real-time observations that the Weather Prediction Center is making, and it's essentially just giving a bunch of statistics just like the Storm Prediction Center does with their mesoscale discussions. Now, both I love equally, but usually severe weather can be more pertinent than flash flooding weather because there are seasons for both, and with certain weather patterns, especially with this record-breaking worst of all time El Nino that is going to be ramping up pretty soon. Actually, it really already is. With all that going on, um, sometimes flash flooding's favored, sometimes severe weather's favored. Sometimes it's kind of complicated stuff. Yeah, but I'm here to come along with you. So we're gonna go from this mesoscale discussion to mesoscale discussion number 277. 81, 80. Yeah, we're gonna go over five mesoscale precipitation discussions. Excuse me. We're gonna go over five mesoscale precipitation discussions: 281, 280, 279, 278, and 277. And the reason why I'm doing five is just because I don't really want to do any more than that. Sometimes the Weather Prediction Center's mesoscale precipitation discussion descriptions can be a little bit wordy and lengthy with multiple paragraphs, but I understand. The Storm Prediction Center, sometimes it's short and sweet, two paragraphs, boom. Sometimes the Weather Prediction Center is five, six, maybe even 6+ paragraphs. Depends on what they're observing. But that's really what I like. I like a lot of information. Anyway, let's get to it. So, mesoscale precipitation, mesoscale precipitation discussions have graphics, just like what the Storm Prediction Center has. They also have descriptions, and they also have what they've used at the bottom. So what they've used is the Geostationary Operational Environmental Satellite 19 CH13 infrared 10.3, and then the RAP 32 mixed layer convective available potential energy at the lowest 90 millibars, uh, and that's it. That's all they used. And so you can see this is the area of interest, and there's text saying isolated areas of flash flooding that will be possible this evening. You can see that these little clusters are thunderstorms. That's a big thunderstorm right there. That's a big thunderstorm right there. These are developing clusters of thunderstorms and rain showers right here. You could see that this is a center of low pressure over, well, blah, 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 Colorado, I think. If I'm not, yeah, Colorado, and then there's a dry line extending from, Montana basically all the way down into more portions of Colorado. So sorry for the little confusion. My brain was just not working. My brain was not braining. So, but yeah, isolated areas of flash flooding will be possible this evening. Now let's read the description. So this one's not as wordy, but it still kind of is wordy. So they do these things: heavy rainfall, right? Flash flooding possible, or flash flooding likely. There's a difference. And the difference is if it's possible or if it's likely. A more likely scenario means that there is more confidence in a worse flash flooding event. So the rainfall rates or the rainfall totals or the progressive nature of the thunderstorms could mean disaster. Could. Not saying they will, but could. So again, 281 to 277. So summary, a north to south axis of locally training thunderstorms along the intersection of the Wyoming, Colorado, Nebraska borders will continue to produce rainfall rates of 1 to 1.5 inches per hour this evening. Localized totals of 2 to 3 inches are possible, which may lead to isolated instances of flash flooding. Discussion. Real-time satellite and radar observations depict a highly organized, north-to-south oriented axis of convection, slowly advancing northeastward across the western high plains. Geostationary operational environmental satellite infrared imagery shows a steady expansion of cooling convective tops, indicative of robust sustained updrafts. This activity is being poorly handled by nearly all the numerical model guidance, but is well supported by observational trends. Water vapor imagery shows strong mid-level forcing and descent associated with an upper-level low spinning over Wyoming and a southward extent of shortwave energy ejection out near the base of it. At the surface, an enhanced lee side trough is interacting with a strong instability gradient. Low-level easterly flow is actively advecting moist and unstable air westward into an inverted trough situated just north of a surface low over far northeast Colorado. This focused low-level convergence is allowing cells and thunderstorms to continuously regenerate and locally train along the boundary. With high moisture efficiency, these cells are producing radar-estimated rainfall rates of 1 to 1.5 inches per hour. The antecedent conditions across this portion of the High Plains are notably dry, which will act as a significantly mitigating factor against flash flooding. However, given the persistence of the convection and the orientation relative to the steering flow, the localized rainfall totals of 2 to 3 inches or greater are achievable through mid-evening. And where these high rates persist over complex terrain, features or localized urban footprints, rapid runoff, and isolated flash flooding will remain possible. Then you can see the affiliated National Weather Services, because WFO stands for Weather Forecasting Office, and that's the office of one sector of the National Weather Service. So you had BOU, CYS, GLD, that's Goodland, and LBF. CYS, I think, is Cheyenne, Wyoming, I think. BOU, that's Boulder, Cheyenne, Goodland, LBF, I have no idea. I have no idea. That's 281, right? This is 280. Now, this is for the slight risk up in Montana, also into the Dakotas, Nebraska, and Wyoming. This is different. This has geostationary operational environmental satellite 18, water vapor imagery, I think that is, WV 6.9, RAP 32, rapid refresh 32, mixed layer convective available potential energy at the lowest 90 millibars, and that's it. So you also have a low in Montana, and you also have this, an arrow. You finally have an arrow. You also have a low in Wyoming as well. You have an arrow. Nice. The arrow is connected to this little bit of text, and this little bit of text says anomalously moist low to mid-level flow. And the whole entire risk area says a general likelihood for some areas of flash flooding will continue through the evening hours. So, see, it says concerning heavy rainfall, flash flooding is likely. So this one is a longer one. See, I told you, it can get pretty long sometimes. Oh boy, here we go. Anyways, summary. broken clusters of heavy showers and thunderstorms will continue to expand and organize across portions of far northwest Nebraska, northeast Wyoming, western South Dakota, and into central and eastern Montana this evening. Fueled by highly anomalous moisture and enhanced surface convergence along an elongated axis of surface low pressure, rainfall rates of 1 to 2 inches per hour will be capable of producing localized totals of 2 to 3 inches or greater. Flash flooding is likely, particularly across sensitive high terrain basins. Discussion. The recent rapid refresh mesoscale analysis and satellite imagery depict a robust upper-level low centered over Wyoming, embedded within an elongated trough stretching across the northern Rockies. This low is projected to slowly lift northward through the evening hours, providing widespread deep layer forcing and ascent. Concurrently, a potent low to mid-level fetch is continuously transporting a deeply anomalous moisture plume from the Central Plains northwestward. Precipitable water, or PW, values within this plume are exceptionally high for late May, running 2 to 3 standard deviations above the climatological means. At the surface, the latest mesoscale guidance indicates the organization of an elongated surface low-pressure center stretching from northeast Wyoming up through southeast and central Montana. This feature is significantly enhancing low-level convergence across the region. Along and east of this boundary, an axis of moderate instability has materialized, with ML Cape values locally exceeding 1,000 joules per kilogram extending down into northeast Wyoming, the Black Hills of western South Dakota, and far northwest Nebraska. And, driven by this combination of deep synoptic lift, enhanced surface convergence, and high moisture efficiency, broken to locally organized convective clusters are expected to produce intense hourly rainfall rates of 1 to 2 inches per hour along this corridor. The consensus of the latest high-resolution guidance, including the 18Z HREF, 18Z REFS, and recent RRFS runs, strongly favor localized additional accumulations of 2 to 3 inches through the late evening. The 18Z HREF indicates areas of 40 to 60+% probabilities of exceeding 3-hour flash flood guidance, particularly across central Montana and the Black Hills. Given some of the flashy nature of the regional terrain and the high efficiency of these convective cores, areas of rapid runoff are expected, which will tend to lead to at least some areas of flash flooding. Got 3 more to go, ladies and gentlemen, boys and girls, whatever you want. Oh, I didn't even see this. There's a low that's basically bordering Canada. Cool. 279, mesoscale discussion number 279. So, as you can see, there's only one thing that's being used, and that's the Geostationary Operational Environmental Satellite 19 infrared depictions. You can see there are thunderstorms over here, over here, over here, and then if you go down over here, and this mesoscale discussion area says, oh, this is for Oklahoma, Kansas, and Missouri. So, this says, localized areas of flash flooding will be possible over the next few hours from slow-moving thunderstorms. This one's also a little bit wordy, but not as wordy. Alright, so, summary. Slow-moving thunderstorm clusters will continue to track east-southeast across southeast Kansas and southwest Missouri through early evening. Rainfall rates of 1 to 2 inches per hour may yield localized totals of 2 to 4 inches, making isolated flash flooding possible. Discussion. Animated satellite and regional radar imagery show an expanding axis of convective clusters stretching across southeast Kansas and southwest Missouri. These clusters have recently exhibited rapidly cooling cloud tops, signaling robust updraft strength and active vertical development, supported by a pooling moisture environment with precipitable waters climbing towards 1.4 to 1.6 inches, and moderate diurnal destabilization. These storms are highly efficient rainfall producers, with recent MRMS data estimating localized rates of 1 to 2 inches per hour. This kinematic environment is characterized by weak mid-level steering flow and small upwind propagation vectors, leading to slow and grinding thunderstorm motions towards the east-southeast. While high-resolution model guidance exhibits typical summer spatial discrepancies, with the rapid refresh forecast system aggressively favoring 2 to 4 inches with localized pockets through 0Z, and the HRRR taking a more conservative 1 to 2 inch approach, the current observational trend strongly supports the higher-end rainfall potential where cells manage to cluster or briefly train. Given the somewhat moist antecedent soil environment indicated by recent NASA Sport soil soil moisture data, infiltration capacities are moderately reduced, and while a widespread event is not anticipated due to the lack of strong synoptic forcing, the slow-moving 1 to 2 inch per hour rainfall rates will be capable of producing isolated, short-term flash flooding primarily concentrated across localized low-lying areas, small creeks, and vulnerable urban intersections. Yippee-ki-yay. I don't know why I said that. I don't know why I'm laughing either. Anyways, so we got two more. This is the second to last one. This is for just strictly Montana. Just Montana, just Montana. And this is very simple. Geostationary operational environmental satellite, basically just satellite imagery. You can see all these, I call these Ryan Hall signals. All of these are basically like just thunderstorm complexes. This is a very simple graph. These green arrows channeling into central Montana say moist, low-level flow and orographic ascent, and the red area is, quote, flash flooding potential increasing. Sometimes when the Weather Prediction Center puts out these very short and sweet graphs, they're kind of scary. This is not so wordy. It may be a little bit wordy, but not really. So, anyways, summary: scattered thunderstorms are increasing in coverage while migrating towards central Montana. These trends will continue for several hours, posing a risk of flash flooding through 21Z or 2 p.m. Mountain Time. Discussion: areas of surface heating have led to sufficient destabilization, or areas of 500 to 1000 joules per kilogram, of mixed layer Cape for scattered thunderstorm activity from west of Jordan to east of Billings and eastward along the Montana-Wyoming border region. These storms were migrating slowly westward at around 10 to 15 knots due to easterly steering flow on the northern periphery of a distinct mid to upper low near northeastern Utah. Northeasterly low-level trajectories were aiding in upslope and subtle orographic ascent across the discussion area, while low 60s dew points and 1+ inch precipitable water values were supporting heavy rainfall beneath persistent, locally backbuilding convection. Rain rates were peaked at around 1 inch per hour per the MRMS, which 1 isn't surprising given the regime, and 2 is approaching flash flooding guidance thresholds, especially closer to central Montana. With time, continued insulation and destabilization within the low-level upslope regime across eastern Montana will continue to support a gradual expansion of convective coverage. Storms could become numerous after 11 a.m. Mountain Time, with the continued areas of 1 inch per hour rates exceeding the flash flood guidance, especially across central Montana. Lighter rainfall rates along Interstate 90 west of Billings, along Interstate 15 through Helena and Great Falls, and across northern Montana near Glasgow could also cause runoff issues given low flash flooding guidance thresholds in those areas. Flash flooding is expected in several areas today. And then 277, it's not as simple. It's not as simple. So we have Nashville, Knoxville. We have two National Weather Service areas, one in Nashville, Tennessee, and one in Morristown, Tennessee / Knoxville. We have We have a black text that says weak winds keeping storms nearly stationary. We have the green that says ample moisture pooling along the front. And this front area says stationary front lifting ample moisture is causing a line of thunderstorms that could produce flash flooding. Now, what they used is the GOES 19 infrared 10.3 and RAP 32 850 millibar winds. That's it. This one is also not as wordy, but everything is just all clumped together. So, summary. Stationary front forcing a line of thunderstorms with erratic cell motions but ample moisture. Localized flash flooding is possible. Discussion. A stationary front denoted by a substantial moisture gradient is providing the forcing for a line of thunderstorms to form from southern Kentucky through the eastern Tennessee portions. Weak but nonetheless sufficient southwesterly flow into the front is allowing the moisture, precipitable water values as high as 1.9 inches in western Kentucky, to lift into the developing line of thunderstorms. Since they are both slow-moving and being reinforced by the moisture advection, expect the thunderstorms to persist for the next several hours until the daytime heating works to disrupt the flow into the front, as well as introduce competing forcing from diurnal heating, cold pools, and in some areas, topography. This will result in a gradually diminishing of the thunderstorms associated with the front itself by late morning. And while the front is stationary, since the overall flow is into the front is stronger from the moist southwest side of the front, expect northeastward drifting of the line of storms through the evening, or through the morning, excuse me. High-resolution ensemble forecast 6-hour flash flood guidance exceedance probabilities show as high as a 40 to 45% in portions of south-central Kentucky and another local maximum in eastern Tennessee of 25 to 30% through 15Z. Cell mergers that are northwest of Knoxville are already causing flash flooding, and expect with chaotic flow along the front that additional cell mergers will occur into southern Kentucky through the morning. What few pieces of high-resolution guidance are resolving the line of storms suggest that there will be a rather rapid weakening of these storms by late morning for the aforementioned reasons, which will diminish the flash flooding threat. Awesome. So I really don't have any much to say because I've said enough. Uh, that I've basically recapped mesoscale discussions that have happened in the past. When I say past, I mean earlier today, these were issued. Some of them were issued just a couple of, maybe like an hour or two ago and are still in effect. Some are not in effect anymore, so you can always do research on that. Um, but yeah, so that is it. Have a great weekend, everybody.